Hello again, YouTube. I'm just going to finish up this mower project, the mower controller. This in the gold box is the human input device. It is basically one momentary switch, one toggle switch, 3 positions, momentary switches, 3 positions, and an endless encoder. Now there is a switch when you press it. I'm not using that at the minute. So power comes in from the tractor. Obviously that's maybe not the best connector that could have been, and then power is transmitted down along with the can high and can low through a 5-pin Eco C. Now obviously I can make a cable, any length of cable within the limits of the CAN protocol specification, which I think is 30 meters, but we're not going to use 30 meters, but I can make any length of cable with 5-pin connector on each side and just insert it into this connection. So at the minute I was testing with this and I've connected up. This is the connector going to the mower and the mower's inputs and outputs, and they are connected through to the various connectors here. And so the human input device or interface device is going to send CAN frames down to this control box, which is then going to turn on and 12-volt actuators, which are going to control the solenoids, which control the hydraulics. So that just leaves the code. Now the last time we just did a quick look at transmitting and receiving a frame, a CAN frame. So there's a piece of test code at the top of this. So if I get rid of test code in both projects, we will look at the real code. And if I look down at the mower first, the control box, there's a status handler. We've been through that. It's just a debug thing. It's printing out status information from the CAN bus, which is asynchronous. We have a few helper functions which set the outputs of the 3 outputs. There's 3 solid state 12-volt switches, well 14-volt switches, the power of the tractor, whatever the alternator's outputting. And we set the swayther, the auto swayther at the back. Depending on its current state, we change its status. Based on the CAN frames that we're getting to a CAN frame handler. So the first thing main does is initialize the various GPIO pins and initialize our frame handler. So this is the CAN frame that we're interested in. So if you look at this, the way we're encoding this, because I've said before, we're not interfacing any other CAN devices. There's no other protocols running, so we can use whatever codes we want. This code has a filter of, if you divide this up into the 11 bits, that's the filter of frames we're interested in, and we've got this pattern of a mask. So what that means is that you can replace each one of these zeros with an X. Am I going into it? Sorry, I went into overwrite mode. So those X's, we don't care what the value of the binary value is, either 0 or 1, we don't care. So what the coding kind of looks like then is, I should have put a comment. So instead of this XXX, what we're actually doing is there are a number of switches. So we want 1110 as the most significant 4 bits. And then this is going to be 3 bits of input, so the input number. Then we're going to get 3 zeros, sorry. This is the actual value we want. So we want 3 zeros there. We want 1 0 there. We want 3 1s there, and this is the status of our input. And that's the way we're coding it. So if we look at the human input side, the human input side is just saying, again, there's a status handler. Now, if there's a change on pin RD0 of the GPIO pin, we're sending, given that format, so we've got the 3 bits for input and 1 bit for status. We are sending an input of 0. So input number 0 and the status is either 1 or 0. So pin RD1 is translating into input 0 when it gets down to the control box. Pin RD1 is translated into pin 1. And again, it's got either a status of 1. The least significant bit is the status. It's either 1 or 0. So the switch is either open or closed. RD2, again, it's pin 2. So we're sending down 721 or 720. This is input 0. This is input 2. The third input, if you count from 0, 1 to 2, this is the third input. And it's either 0 or 1 is the status. Same again, RD4. And that's all that's happening. So on the human input device, we are just sending a status. And anytime there's a change, we put together a frame and we transmit it. So all the main does is set up the GPIO pins, create the kind of empty. We're actually registering a handle here because I was going to bring status messages back from the mower controller. I may actually add. That's one of the advantages of this system is that we're not fixed. We're using a digital interface to send and receive messages. So I may at some point add. I think one of the problems might be a fluctuating oil pressure. That the PTO from the tractor drives a motor or a compressor which creates hydraulic pressure on the mower. So the mower has a separate hydraulic system from the tractor. So the mower is creating its own hydraulic pressure, and there may be fluctuations in that pressure. So I might at some point in time put a pressure sensor on the mower controller. But then the mower controller can send back up to this human interface device a frame with the pressure value. And that would require a change to the control for the human input device box, so that it'd have some sort of screen on it or some output, so that you could see what that was, the oil pressure. But that's for a later date. We'll see how this goes. But that's the basics of the human input device. It just sends the pin number, or sorry, the input number and the status. It's either open or closed. So in RS 485, that protocol talks about coil status. So this is more or less the same. It's either open or closed, on or off. So on the control board side, again, all it does is register this handler. So we're interested in any CAN frame starting with 1110. and then three zeros. We're interested in 3 zeros there. So I should maybe put the X's in that position. So that's the frames that we're interested in. Binary 1110, don't care, don't care, don't care, 000, and don't care. And they're all going to a frame handler, and the frame handler just receives those can frames and acts accordingly. So depending on where the swayther is, it's going to set the swayther up and stop the belt, or set the swayther down and start the belt. And that's it. There's not a lot of code here. Few hundred lines. I leave it there. I'll try and attach a video of, I'll try and put this into do a simple test in it. We're going to have to do more testing in the field, if you excuse the pun, and I'll try and tack that on to the end of this video. And yeah, we'll leave it there for the minute. Thanks a million for watching.